Physicists and mathematicians are currently investigating whether everything you perceive, from the chair you're sitting in to the stars overhead, is actually constructed from algorithmic code. This inquiry has moved from the realm of speculative fiction to the lecture halls of global institutions, where the fundamental nature of reality is being interrogated through the lens of information theory. The modern framework for this debate started in 2003 when Oxford philosopher Nick Bostrom published a paper outlining the simulation argument. Bostrom's argument centers on the sheer scale of future computing. If an advanced civilization survives to develop massive processing power, they could run trillions of historical simulations, creating billions of digital minds that possess a sense of consciousness identical to our own. This leads to the trilemma. We either go extinct before reaching that stage, or advanced societies lose interest in simulating their ancestors. But if we believe that civilizations like ours eventually reach that level of power, we face a statistical reckoning. Simulated humans would vastly outnumber the biological ones, making it nearly certain that we are the ones living inside the machine. To find evidence for this, we have to look at the smallest possible scales of matter, where classical physics gives way to quantum mechanics. In quantum mechanics, we encounter the observer effect. Experiments like the famous double-slit test show that subatomic particles exist as undefined probability waves until they are actively measured or observed by a sensor. Computer scientists recognize this behavior immediately. Modern video game engines use a technique called lazy rendering to conserve processing power. The system only draws the high-resolution environments that the player is actively looking at. The unobserved world remains a mathematical abstraction. Physics has a resolution limit. The Planck length and time are the smallest possible units. The universe cannot be divided further. The speed of light is simply a particle moving 1 Planck length per clock tick, a hardware constraint representing the grid's maximum refresh rate. From quantized energy to on-demand rendering, the subatomic world behaves like a digitized system, employing memory-saving shortcuts. But the simulation hypothesis has a major problem, and it comes from astrophysics. The mathematics of computing are bound by strict laws of thermodynamics. Astrophysicist Franco Vazza recently calculated what it would actually cost to run a simulation of our universe. Because information is physical, every computation requires a specific, unavoidable amount of energy. Vazza applied these thermodynamic laws to map out the hardware requirements. Simulating the quantum mechanics of the entire universe is impossible, so Vazza calculated the energy required to simulate just the Earth. The results break the hypothesis. A Planck-scale simulation requires vastly more energy than exists in our entire observable universe. The hardware constraints are absolute. You cannot build a computer capable of continuously simulating this exact physical reality because you would run out of energy before you even finished rendering a single planet. This is where the simulation argument pivots. Nick Bostrom explicitly anticipated this thermodynamic roadblock and provided a massive software loophole. A simulator doesn't actually need to compute every quark and electron on Earth. To create a successful simulation, the program only needs to provide a continuous, coherent stream of sensory data to a conscious mind. It just needs to trick our subjective experience. The microscopic structure of the Earth's core doesn't need to be persistently rendered. Distant galaxies can be low-resolution background images. High-fidelity details only need to be generated ad hoc, precisely when an astrophysicist looks through a telescope or a biologist uses an electron microscope. We know for a fact that our physical reality features quantized limits, maximum speeds, and observer effects. But assuming these are the deliberate optimization tricks of a conscious programmer pushes us out of empirical science and into pure philosophy. It also creates a massive logical trap called the infinite regress. If our universe is a program running on a computer, what physical laws govern the base reality where that computer was built? And what guarantees that their reality isn't just a simulation running on an even larger machine? Whether we are biological entities experiencing a physical cosmos, or lines of code processing data in a simulated void, the result is identical. The line between the observer and the observed disappears. Our reality is, at its core, constructed of information. Which leaves us with the ultimate question. If we are simply software running inside a machine, living out pre-calculated routines in an artificial cosmos, would knowing the identity of our programmer actually change how we search for meaning?